Welcome back. So, since everybody seems to have one of these devices in their garage or in their house, I figured I might as well make a video showing you guys how to prevent them from breaking down and how to fix them when they do break down. And this is an electric dryer. So, as part of the new format, we're going to be drinking beer and fixing things. So, we'll start out. This electric dryer, I already tore it down. Why not? It was dirty. It was extremely dirty because the stupid owners that had it before me, they didn't feel the necessity to put the filter trap in there. And because they didn't put the filter trap in there, I had lint up and around the heating elements, and I had it all up here in the plenum and around the squirrel cage fan. And in the discharge tube was completely clogged full of lint. And you want to talk about a fire hazard. It's an insane amount of lint floating around inside this unit. So they pretty much negated most fires by drawing air in here through the back. It goes around the heating element, and then it comes in the back of the drum through your clothes, and then it comes through here, which would be your filter trap, and then it goes into your circulator fan and out into your house or out of the house, however you have it set up at home. So anyway, that's the path of air. So basically, if you keep this cage clean in here, it's not a fire hazard. But when you don't have a filter trap, there's little holes, like even around here, where lint will discharge into the cabinet. And when it gets in the cabinet, when this thing is sucking air in past these heating elements, lint will gather on it. And just to prove my point, you can see where there's already been little fires. So up there you can see it got really hot. There's some lint that was trapped there. There's some lint that was trapped there. And hopefully what will happen is it will get so hot because of black tubes that one of these thermal fuses, here's the thermal fuse. We have probably a thermal disconnector up there which helps adjust the temperature, and there's a thermal fuse. And here's a thermal fuse right down here on the blower fan. So one of these should disconnect electricity, and then it'll either throw an error code or it just won't turn on. One of the other symptoms is that the unit will spin, but it won't heat. And one of the other symptoms is that the unit won't spin at all. So it depends on which one of your thermal fuses goes bad. And this one here, you can tell, is probably a thermal fuse that disconnects your heating element from your 240 volt. So anyway, I'm going to show you guys a few of the things that goes wrong with these. I'm going to show you guys a few of the things that goes wrong with these devices, and maybe you can diagnose your own problem and fix it instead of leaving it out next to the curb like these poor souls did. This dryer has plenty of life left. All they had to do is put a filter trap in there, collect that lint, instead of blowing it throughout the whole device and contaminating the whole device. So all I had to do is pull this all out, clean it, which took a long time, clean the filter trap housing and this little plenum right here that also contains the filter trap. And I had to clean the drum because there's a bunch of garbage stuck up there in the rear of the drum where it sucks the hot air in. So I'll get right into it and show you guys how to diagnose your heating elements. First off, it's a very common problem, especially if the heating elements get too hot, that they will pop. And what that means is that one of these will probably break open, and when you have an open someplace, no current can flow, and it basically kills your whole heating element. So in order to test your heating element, you can either have it your multimeter, you can have it on continuity, which would be this one right here. With continuity, let's see if I can do it better like that. When one probe has a path to the other probe, it should alarm and it should give you an ohm value, which is your resistance. Now, since heaters operate by resistance, you will have some sort of resistance, and it should show continuity. If you have no continuity, you don't hear a beep, then your heating element's bad. And this is actually probably a cheap part, because that feels like some cheap composite. It's just held in by these little metal latches. So you probably just bend the latches out of the way and put a new heating element in. So anyway, I'll show you how to measure these. You can see right here, there's a couple bus bars. So I don't know which is hot and which is neutral. Usually white's neutral, but don't ever go by that. And you can see that you have a bus bar over here. So what's going on is this one here is probably for low temperature, and it only heats up the outer ring. And this one here is probably for high temperature, and it'll probably light this one and this one. So high temperature, you got these two and this one that are gonna get lit up. And you know this because right here is your common return bus bar, and it covers all three of them. So that's how you know. There's that one, that one. So there's 3 different things that we're gonna measure here. So what we're gonna do, let's see if I can measure this a little bit better. One of your leads, I just got it crammed up in there, but one of your leads will go on that side, and we're gonna measure just that row. So you come around this side, it's good. We'll drop it down to the next one. Normally I would just touch the bar and then touch the other bar with my hands. Mind you, this dryer is not connected. The electrical cord plugs in down there. It's unscrewed. I'm on the other side of the garage. Don't try this with your dryer plugged in. I mean, please, this is crazy. So we'll try the second row. Looks like the second row is good. And we'll try the third row. Okay, third row's good. So the heating element is just fine. So what could be also wrong with this thing? Next would be a thermal fuse. So what happens, I've got a thermal fuse right here. This one came out of my fireplace. The guy that used to own this house ripped out all the wiring because his fireplace quit working, and he'd rather have a trim looking fireplace than a functional one. It was really just this part. So this is what, $13 part, and I had a working fireplace. So you can see there's 2 spade connectors here and here, and that's all you normally see, but I have this one cut away so that you can see what happens on the inside of a thermal fuse. Here's the button, and the button faces the heat source, which you can see here is going in the squirrel cage fan, and this one here you can see that it's going inside the heating cage. So when you have heat on this side, it's going to force a plunger up to separate these 2 contacts. You see how the 2 contacts are right there. So it pushes up at a certain temperature, separates those contacts, and that's your rating of your thermal fuse. Like this one here might be 185 degrees Fahrenheit. At 185 degrees Fahrenheit, it's going to pop open, and some thermal fuses will reset. You know, you let them cool down for like 15 minutes and then they go back to normal, and other ones are permanently broke. It's done, it's gone. And this one here, I don't know if this was a resettable one or permanently broke, but I'll show you exactly how to test a thermal fuse. So I got my meter here. Put one lead on one side, one lead on the other side. Kind of awkward doing this with one hand, of course. Okay, one lead on each side. Okay, you can see right there, my thermal fuse is open. Here, there we go. That's right on the spade connectors. You can tell my meter's reading infinite, which means it's open. And we can also test that. Hold on just a second. Should definitely do this with a tripod from now on. You can also test it by opening up and pushing down on the middle part, and then you'll see a resistance. Doesn't do you any good. Once you open it up, it's pretty much already invalid. So this is garbage. Get a new thermal fuse. So the important thing to remember when you're testing thermal fuses is one of the leads has to be disconnected, because someplace further down the circuit it could be closed, and it gives you the impression when you measure across that it is actually a closed circuit. You have to have one of them off. Here you can see one of mine is dangling. And you can tell right there, one-handed. You can hear my meter. See the resistance, 0.001. That is a good thermal fuse. So, with these dryers, just be cognizant that you're either going to have a thermal fuse that's bad, or hopefully you're using your filter trap, because if you're not, you're going to spend a whole day cleaning like I did with this one. And you're probably going to burn your house down like this one almost did. But dryers are very simple, and 90% of the time it's a thermal fuse. They sometimes just pop, whatever. I'd say 10% of the time that I've had to repair dryers, it's actually a heating element that's gone bad. But between the two, you'll almost always get them up and going. So please feel free to let me know if you have any questions. I fixed many of these units, and this one here, I'm going to put it back together right now and give it a test. Thanks for watching, guys.